Hello my dear students. Today we are going to continue our topic about measuring simple harmonic motion. We have studied in section 1, chapter 11, section 1, simple harmonic motion, and we have said that simple harmonic motion, it's like the motion of simple pendulum and like the motion of mass and spring system. So today we are going to continue about simple harmonic motion, but another new terms about this topic, like amplitude, period, and frequency. Again, we have some new terms about simple harmonic motion, which are amplitude, period, and frequency, which we are going to discuss it about, explain it in this section. First one is amplitude. Amplitude means, if you see here the simple pendulum, the displacement, the maximum displacement like this away from the equilibrium position is called this amplitude. Again, the maximum displacement away from the equilibrium position is called displacement, even for the right side or the left side, it doesn't matter. And here also, not only the simple pendulum, also the mass spring system, also in the mass spring system, if this mass is stretched to the left side, to the maximum displacement from the equilibrium position, this is the equilibrium position, the dotted line, or even compressed to the right side away from the, again, equilibrium position, it is called amplitude. So amplitude is the maximum displacement away from the equilibrium position. For the pendulum, it can be measured by the angle. Can you notice this angle between the equilibrium position and the maximum displacement? By measuring this angle, you can know if the amplitude is high value or low value. For example, if this angle is very high, it means that the amplitude is very big, and if it is low, it means that the amplitude is low. Similarly, in the mass spring system, the amplitude is the maximum amount that the spring is stretched or compressed from its equilibrium position. Stretched to the right side, for example, or compressed to the left side away from the equilibrium position, also is called amplitude. Amplitude, by the way, is measured by meter. Since its displacement, maximum displacement is measured by meter, as you know. And here is another SI unit, which is called radian. So the SI unit of the amplitude are radian, RAD, and meter, both of them. The second one is period. Now we have finished the first one, the first term, which is amplitude. The second concept is period. Period means what? Here, if you notice the simple pendulum, the time taken by this pop away from the equilibrium to make one complete cycle. Again, the time taken by this body, the vibrating body or the pop of the pendulum, to make a complete cycle, it's called period. So period is the time that it takes to complete cycle, that it takes a complete cycle to occur, which is measured in seconds. Since it's time, so it's measured in seconds. So what about the number of oscillations or number of vibrations or number of cycles taken by the body in 1 second or in a unit time? It's called frequency. So frequency means the number of cycles or vibrations per unit of time. The number of cycles or vibrations per unit of time. And its measuring unit is hertz. By the way, hertz equal second power negative 1. S power negative 1 means second power negative 1. Why? Because frequency simply equal 1 over T, period. So it is the reciprocal of period. And T, the periodic time, equal 1 over F. That's why hertz equal second power negative 1. Why? Because period and frequency are inversely related. So, but for example, if you know that the frequency, if you can't know the quantity of frequency and you know the period, you can easily calculate the frequency value by knowing the other one. So at any time you have a value for the period of frequency, you can calculate the other value. For example, if the period equal 5, so frequency equal 1 over 5. If the period equals 10, so the frequency equal 1 over 10. And also, if the frequency equal 6, so the period equal 1 over 6. If the frequency equals 3, so the period equal 1 over 3. So now we have finished amplitude. What does it mean? Frequency and period. Okay, now let's see how can we calculate the period. Let's see how can we calculate the period for both of them, simple pendulum and mass spring system, because there are two different formula for each one. But let's summarize. What did you take now? Amplitude, as we said, it's a maximum displacement from equilibrium and measured by radian or meter. Period, it's a time taken by the body to complete a full cycle, and it's measured by second. Frequency, the number of cycles or vibration per unit time or per 1 second, which is measured in hertz, as we said. So there are the main concepts related to simple harmonic motion. Now let's see how can we calculate the period. How can we calculate the period for both simple pendulum and mass spring system? In the simple pendulum, we are gonna use this formula. Actually, the period of the simple pendulum depends only on the length and the free fall acceleration or the gravitational force. Only for the length, depends on the length and free fall acceleration. So T period equal 2 pi square root L over AG. AG, by the way, means G, gravitational force or the free fall acceleration. So again, period equal 2 pi square root length over free fall acceleration. So it depends only on the length and free fall acceleration and doesn't depend on the mass of the bob or on the amplitude. Again, it doesn't depend on the mass of the bob or on the amplitude. What about for the mass spring system? For the mass spring system, the period depends on the mass and the spring constant, K. If you remember, we studied before Hooke's law in section 1. Okay, so this equation, by the way, applies only for the systems which obey Hooke's law, because we are gonna talk about the spring constant, K. If you remember, the elastic force equal negative Kx. Hooke's law said that. So T here, the period equal 2 pi square root M over K. 2 pi square root mass over the spring constant. The period only depends on the mass and the spring constant. Mass and spring constant. And it doesn't depend on the amplitude either. Okay? And as we said, this equation applies only for the systems in which the spring obeys Hooke's law. Okay. Now, let's see a sample problem. How can we calculate the period? A desktop toy swings back and forth once every 1 second. What is the height of this toy? Assume that G equal 9.81 meter per second power 2. Now we are gonna calculate L. What is the height of this toy? Means L. Here is the period and here is AG. Let's see how can we calculate it. So now we have T equal 1 second, AG or G equal 9.81 or 81 meters per second power 2. Since this is the rule, we are gonna use T equal 2 pi square root L over AG. To get L outside of, extract L from this equation, it will be like this. We are gonna make square for both sides and then get L at the left side alone in one side, and it will be like that. So L equal T power 2 G or AG over 4 pi power 2. By substitution, L equal 1 power 2 multiply 9.81 divided 4 pi power 2, so it will be 0.25 meter. Here are some examples. You can solve it and to apply for the rule. Okay, here are 4 problems about the period. How can we calculate it, the period or the length? See you next time. Bye bye.